Hello everyone, it's Prajwal Pathak this side and you're watching my YouTube channel pyGuru. Friends, this is a fourth tutorial in our game development series of Tetris with Python pygame. Okay. In the last tutorial, created our shapes and made them move towards the left, right, or to the bottom direction. But we were not checking for the collision detection. Our shape was able to move toward the or move out of the window both in the left and the right side and in the downward direction. So we have to check for collision, okay, so that we can stop the shape to move toward the left or the right or get out of the window. Okay, now for this what we are going to do is we are going to create a method called intersects. Okay, this will check if our shape is intersecting with the left border, right border, or the bottom border, or with any other shape. So let's just get started without wasting any time. So def intersects, and for this, first of all, we are just going to create a variable intersection. We will initialize it with false. It means currently our shape is not intersecting with any other thing, neither with the left border, nor with the right border, nor with the bottom border. Okay. Once again, we have four types of collision: with the left border, right border, bottom border, or with any other shape. Okay. We have multiple shapes, so we have to check for collision with multiple shapes also. So we know that our shape is a 4 by 4 matrix. Okay, here we saw that our shape is actually a 4 by 4 matrix, but not all of this is actually the part of the shape. Okay, uh, let me just show it in the paint so that I can explain you better. See here, this is our matrix, and let's consider the first shape here, 1, 5, 9 and 30. This is I, and we will just consider the first sublist of this, 1, 5, 9 and 13. Okay, so let me just take the fill option here. So this is the 1, 5, 9, 13. See, our shape is though a 4 by 4 matrix, but not all the cells are filled. Okay, the left column is empty, it's simply 0, 0, 0, 0, and the right two columns are also empty. Only one column is filled with values. Okay, so not entire 4 by 4 matrix is part of our shape, only one column is here. Okay, similarly, let's consider this another shape. Let's say 1, 2, 5 and 6. Okay, so this is 1, 2, 5, 6. So this basically makes a square. Again, not entire 4 by 4 matrix is part of our shape, only these four cells are the part of the shape. So these are empty, we do not have to care about them. We have to care about these four cells which are filled with some value, okay, greater than 0. So for this, first of all we need to find out the value, to find out all the cells we have to use two nested for loops. You can create it like this: for I in range, let's say 4, for j in range 4. This is how we can create a nested loop. For I in range 4, for j in range 4. Okay, now what I was saying is that not the entire 4 by 4 matrix is our shape. We have to only take care of these values, these four cells in the shape O. Okay, it will be different for different shapes. So we can check if a cell is a part of cell shape like this: if I multiplied by 4 plus j. If you are using a nested for loop like I and j, using I and j, you can get each cell using this calculation: I into 4 plus j. And we have to check if the I into 4 plus j if I into 4 plus j in self dot figure dot image. We have a method image here in our tetramino class which returns simply the current sublist. Let's say in the case of O, it will simply return this sublist 1, 2, 5, 6. In the here it will simply return the first sublist. If rotation increases, this will return this sublist like this. Okay, so if it is a part of this sublist, then means it's a part of shape. Otherwise it will simply exclude these values, or it will only consider these four values. Okay, this if condition. Now here, to check for the collision detection with the left border, we can do a simple thing: if j plus self dot figure dot x. Now remember, we had passed two values to our tetramino class, which is x and y. Okay, x and y here. So x represents the initial position of our shape, which we have passed 5, y is 0. Okay, so we are simply adding if j plus 5 is less than 0. Okay, then it's a collision on the left border. We can simply make the intersection equals true. Finally, we can simply return the intersection from this method. So return intersection. That's it. Okay, now once again what we are doing, if j plus self dot figure dot x, okay, so j is initially it will be 0, okay, for here it will, for this column j will be 0, for this column j will be 1, 2 and 3. Okay, so let's say here 0 plus 5 is less than 0, it means it's colliding on the left side. If it is colliding, then it's an intersection. We will simply make the intersection true and return the intersection. We have to check 3 more conditions, but we will check it a moment later. Now here we have moved towards the left, and now we will check if we are colliding with the left border. So if self dot intersects, this is our method, sorry, intersects. So if it's collision on the left direction, what we will do, we will simply self dot figure dot x minus equals dx. We will simply do it. Okay, now what this will do, we are adding the value of dx. It can be either plus 1 or minus 1. If we are moving to the left, it will be minus 1. Okay, so let's say the value of self dot figure dot x is 5. So if we subtract 1, it will become 4. So it will be in the 4th row, then 3rd row, then 2nd row, then 1th row, then 0th row. Now it's in the 0th row, it means it's in the top left corner. If you subtract 1 further, it will go out of the window in the left direction. So it's a collision here, and since it has moved 1 towards the left outside the window, so we'll simply add 1, we will subtract minus 1 to it. So minus into minus, it will become plus 1, so it will just get back inside the window. If I just run this program, you will see our shape will not be able to move to outside the window. See, it's not able to move outside the window. It's working fine. Now let's check collision for the right direction. We can do it like this. If like this, j plus self dot figure dot x is greater than self dot calls minus 1. Okay, now we have here written 2 if conditions. If you want to combine them, you can use the or here, or. Okay, now since we have written these 2 conditions in separate lines, we have to use a backward slash here, otherwise it will give an error. Okay, so basically this will check the collision on the right direction. If I just run this back, this should check for the collision in the right direction. So let's see if it's working or not. Yes, so we are not able to move back towards the right direction also. Similarly, we have to check for the collision in the top down. Okay, so bottom border. So we can check it like this. If I plus self, see, currently we were checking for the left or right collision, so we were using j. Now we have to check for the downward collision with the bottom border, so we have to use the I, okay, of the nested for loop, since it's representing the rows. I plus self dot figure dot y is at any time greater than self dot rows minus 1. It means it's a collision. Okay, so again we can just combine them using the for or. And now since I have written on a separate line, again we have to use the backward slash. Okay, this is simple. Now it will check for a collision. Okay, so if I just run this, it will not make much of a difference here, but let's say here we can put it here currently we're manually checking if self.figure.y is greater than self.rows, then we were creating a new figure. So instead we can do something like this. If self.intersects, okay, and then what we can do, we can create a new figure. If we want, we can create a new figure. Basically what we have to do is that we have to freeze the shape at that particular position. Okay, but we are not currently freezing it. We will simply create a new figure. And one more thing we have to do is we have to just subtract y 1 from it. Okay, so we can do something like this, minus equals 1. This will do the job. If I just run this, it will not make much of a difference in the previous program. Our shape will still just go out of the window, but a new shape will be created soon it touches this thing. Okay, see, a new shape was created soon it touches this. Initially it was creating when it goes out the window. Now we have to think of some way by which we can freeze our object. Okay, we can freeze the shape once it reaches the bottom. So for this, what we are going to do is we are going to create a new function or new method here. depth freeze like this. And basically the job of this method is to freeze your shape once it reaches the bottom or once it collides with any other shape. So again we can just copy these 3 lines here, paste it here. Okay, since we need to find out all the values of the shape. You can freeze it like this. See, currently our shape is independent of the board. Though we have created a board here, our board is filled with all zeros. It's not filled with any other shape. The basic concept, the basic logic that I'm going to use is that once it reaches the bottom, we will transfer all the values of our shape. Let's say in this case, all the values of this shape to the board. Initially the board is 0, 0, 0, 0, and this shape is independent of the board. It's just moving downwards, okay? And it is not affecting the board in any way. But once it collides the bottom, we will transfer all the values of this shape to the board, okay? So we'll just fill or pass the respective values or respective cells of the board and fill it with the values of this shape. We can do it like this: self dot board, okay? And here I plus, we can do something like this: I plus self dot figure dot y. Okay, and this is for the height or row. Okay, first of all we need to find out the row, then the column. So j plus self dot figure dot x. Okay, and we will fill it with the value of figure, self dot figure dot color. Okay, remember our figure has a value in it, color. Okay, it's the value 1, 2, 3 or 4. Okay, so basically these all squares are filled with 1. Let's say the random value is 1, so all square has a value, or this cells has a value 1. Okay, so we'll just transfer all the values of our shape to our board. Okay, so this will simply fill the board. It looks good now. Now once it freezes, what we'll do, we'll just create a new shape. So we can just cut this thing here, we can just cut this thing and paste it here. Okay, instead here we can just call the self.freeze method. So self.freeze once it reaches the bottom. Now it looks good, and let me try to run this, but before that it will not make any much difference. Instead we have to do one more thing. Currently we are displaying the shape, okay, only the shape, independent shapes. We also have to draw the values of the figure of the board which has value greater than 1. So we can do something like this. Now remember, this thing is for displaying the shape which is independent of the board. Okay, it has nothing to do with the board, and this thing or the code that we are going to write, it will display the board. Okay, board values which has values greater than 1 or which we have just transferred. So for, we can do it something like this: for x in range rows, for y in range calls, though. Okay, if Tetris dot board at any position of any x comma x y is greater than 0, it means there's a shape. So what we can do, first of all, we'll just transfer this value or store it in a variable called value. Okay, and then the next thing that we have to do is we have to figure out the image that we want to display at that position. So we can get it like this: assets val. Remember, let's say our shape square has all the values 1, 1, 1, 1. So we will just transfer it to the board, so that border at the bottom border, the board values will become 1, 1, 1, 1. Okay, so we know that for the 1 we were using the blue color, so we have to display the blue color. Okay, now we just have to display it. So win.blit, we have just selected the img. Let me just cut this thing. So img and the position. Now position will be a little tricky here, or basically it's simple, very not much difficult. So cell size x multiplied by cell size. This will do the job. Okay, this is the x position of the image, this is the y position of the image. Okay, so this should do the job, and if I just run this, it should give me some output. Let's say if it's working or not, or if it's freezing or not. Okay, see, it's just freezed here. Okay, so our shape is freezing once it reaches the bottom. It's looking good. Our shape is just freezing like this, but it will currently we are not checking collision with any other shape. So see, it will just go out above the shape. So we are not checking collision with any shapes. We have to also check it. Let's just add the collision with other shapes too, and we can do it here. Again, it's very easy to add check collision with any other shape, and this is basically this thing. We will just write or and then use a thing like this, and here we will write if the self dot board. Now again, why I am using these backward slashes, because I am writing the conditions on multiple lines. To separate multiple lines, you have to use the backward slash. Okay, if self dot board I plus self dot figure dot y, and here j plus self dot figure dot x is greater than 0 at any condition, then again we have a collision. Okay, so oops, sorry, let me just fix this thing. Okay, now this should work. This will check for collision detection with any other shape. So if I just run this, basically this will also check for the collision with the other shapes. If I just go down, yes, see, it's working. Okay, it looks good. Okay, so all the collisions are working perfectly. I'm able to rotate things. If there's a bug, just tell me in the comment section so I can fix it in the next tutorial. Okay, yes, it's working fine. Now the next thing that we want to do is, I wanted to add one more thing. If I just press space, currently we're pressing the down arrow key. We have to keep pressing it for some time to make the shape fall. I want to do something. I want that whenever I press space, the shape will just fall directly toward the bottom. Okay, so I'm just going to create a new method for this. Def go down, go side, and let's just create one more method here. Def go space. So we don't have to wait for some time to make the shape fall. Okay, we can simply press the space and it will directly fall. Here we have to use the self keyword. And what this logic is, while our shape is not intersecting, okay, with anything, so while not self dot intersects, basically it will check while our shape is not intersecting with the bottom border or with any other shape. What we will do is, we will simply keep adding self dot figure dot y plus equals 1. We will keep making it falling. Okay, and once it collides, what we will do is, we will simply subtract it 1 from self dot figure dot y minus equals 1. If we don't do it, you will see that it just goes one cell above the another shape. Okay, that's it. Finally, we will simply freeze it. Once it collides with any other shape, we will simply freeze it. Now we have to call this method, and we can just put it inside here in the event handling part. So let's say after down, let me just copy this line and paste it here. Okay, so here we can check for if we are pressing space. So what we can do is, we can simply write Tetris dot go space. Okay, you can directly call this method, and this should work. If I just if I just press space, it just falls directly. See, we don't have to wait this time now multiply. It looks good. Okay, now see, though we have reached here, the game is not getting over. New shapes are keep generating. So we have to implement two things here. We have to destroy the line once we complete the thing. Okay, currently let me just try playing it once, and we'll be adding in that next tutorial. Let me just make it fall. Okay, the next objective of our video will be to remove the line. Okay, let's say yes. So see, the bottom line is completed. I want to remove this line, so we'll be removing this line in new part next tutorial. We'll also learn how can we represent what is the next shape that is coming, that will show here. We will also show the score. So this will be, we will do it in the next part. Okay, so yeah, this is it for this video, guys. If you love this video, leave a like or a dislike. If you're new to my channel, subscribe it. Thank you. See you in the next tutorial.